Okay, so let's discuss a question from machine design. This is basically a bolted joint question from the bolted joint. So you have a cantilever kind of an arm steel bar which is bolted to a support by at A and B, and you have a load that is getting applied as shown. So this is something like eccentric bolts, and you need to find out what is the shear load first coming at A and B, and then based on the load we have to decide which is the shear loaded bolt, and then find out the shear stress. So first, to get the load, what you need to do, because it's an eccentric load, so directly you cannot get the load. You have to decouple into primary and secondary. So the primary bolt will be basically, what you do is, this load P is any force P can be seen as a load and a moment at any other point, right? So this is moment and this is load. So this load P can be seen as a load P and a moment at the centroid of A and B. So always what you have to do is you have to choose a centroid between A and B, because there are two bolts, so the center will be the centroid. Center between the two bolts will be the centroid. At this centroid, this P will have an effect of the load P and the moment M. So because of this primary load P, secondary load is moment P, so this load P will try to, actually you have a bolt A and B and you have a P acting here, so this P will be producing a load of P by 2 and P by 2 on each of the bolt, right? So these are the primary load, which is P by 2 on each of the bolt, which is nothing but 4 kilonewton, that is 4000 Newton by 2. So 2000 Newton is acting on each bolt. Okay, so that is PA 2000 Newton and PB is 2000 Newton. Okay, now coming to the secondary load. Secondary load, you have to just pay attention how do we get. So secondary load is the moment, and this moment is P into the eccentric value. So remember that this is P, and this value, that is from the center of the bolts to the point where load is acting, that is total E. So this E is basically this length 1.7 meters plus this is nothing but 300, this is 200 plus 100, 300 mm, that is nothing but 0.3 meters. So 2 meters is the length, eccentricity. So this load, that is 4000 into 2 meters, so that is 8000 Newton meter is the moment that is acting at the centroid. So let's see how this produces. So you have a load here, you have a load here, this is the centroid. Let's call this as LA, that is from the center of the first bolt to the center of the bolts, and this is LB. Both are same here, but just to generalize. And this moment is M. So this moment M will produce a secondary load on A in this way, let's call it SA, and on B in this way, because this again depends on the direction of movement. So this movement will try to produce an SA and SP on this. So how do you get this SA? See, this is how you solve for the secondary movement. So this movement will be SA into LA, okay, plus SB into LB. Okay, the effect of the moment will be sum of the total moments of A and B about center. Okay, but now there are two unknowns here, SA and SP. So SA and SB, again, the farther the load, the lesser will be the load. The further the bolt from the center, the lesser will be the load. So that, it's kind of an assumption. So SA by LA is SB by LB. So this is something which we make the assumption, because otherwise from one equation you will not be able to find out SA and B. So further the bolt, lesser will be the effect of the moment, and therefore the lesser will be the load. So SA by LA, we assume that SP by LB. But remember that LA and LB are both same and are equal to 200 mm. So LA by LB are both same and equal to 200 mm, that is nothing but 0.2 meters. So going by this first we'll get SA is equal to SP, right? And then we substitute it here. So moment already we got as 8000 Newton meter. SA is basically same as SP, so it is twice SA LA and SA into 0.2, right? So from this what we get is SA is 4000, that is 4000 by 0.2, that is nothing but 40,000 by 2, that is nothing but 20,000. And SP is also same because SA and SP are same. So 20,000 is the secondary load. So now if you combine this primary load and the secondary load, the total load that is coming is on the bolt A, PA is down but SA is upward. So there is a SA is 20,000 minus 2,000, so 18,000 is the load on SA. SP, PA and SP both are down. So 2000 plus 20,000 is 22,000 newtons on B. So B is the most heavily loaded, and so obviously we need to design based on B. So the shear stress based on B will be the total shear load, both combining primary and secondary, by area of cross section. Remember it's M12 bolt, so nominal dia is 12, so pi by 4 into 12 whole square into 22,000 newtons. So 22,000 newtons by pi by 4 d square, so this gives 195.4 MPa. So the answer is so this is Newton per mm square, so MPa 195.4 is the stress on this bolt. So this is a big problem, but it's informative. So 195.4 is the answer, close to 195. Thank you.